Hello, dear colleagues. My name is Mykola Khandoga, and today I will tell you about our experience in fine-tuning Gemma and Mistral LLMs for the Ukrainian language representation. This experience we have called from Bytes to Borsch. Our starting point is motivation. Why do we do fine-tuning at all? What's wrong with the current state of things? The problem with modern LLMs is that they actually should be called large English models rather than large language models, and they do struggle with other languages than English. For instance, recently Llama 3 was out, it was a huge success. However, according to Andrei Karpaty, most of its dataset is English. It was trained on English corpora, first of all, and only 5% attribute to all the other languages. That leads to immense cultural bias, and then that's one of the problems. Next goes tokenization. Here you can see the result of tokenizing the same text with roughly the same number of characters in English and Ukrainian using the official ChatGPT tokenizer called TikTok. What do we see here? As we know, the models don't see characters, they see tokens. Uh, in this situation, when English tokens are longer, the entire text looks shorter to the model itself. That means larger context window and cheaper usage of the models. So Ukrainian language with smaller tokens is a huge disadvantage in this situation, which is, of course, unfair with respect to Ukrainian language and, to be honest, most of other, first of all, non-Latin languages. Another problem that might be encountered due to partially tokenization, partially underrepresentation of the languages in the dataset is code switching. Up until recently, code switching was a phenomenon known primarily to linguists who worked with humans. Code switching is a phenomenon when a person uses two languages at once in the same sentence, like the kids you see on the left. However, as of a few years ago, with the development of the large language models, they started to develop a phenomenon very akin to those that Ukrainians see in their everyday life when people mix two different languages in the same sentence. Uh, Often, this phenomenon is called after Prime Minister of Ukraine Mykola Azarov, who was mocked a lot for his specific way of code switching all the time. Uh, we have experienced this particular phenomenon in the course of fine-tuning our language models, particularly Gemma. You see a couple of examples presented here, but also other languages, especially non-Latin, do experience very similar problems, as you see on the example in the left bottom. So that's another disadvantage that comes to non-English and especially non-Latin based languages. So all the factors listed above, why not contribute to the fact that it's so hard to make a really multilingual model? Uh, Bigger data set is hard to get. It leads to more expensive training. Bigger vocabulary leads to larger model and more expensive training. Technical difficulties create code switching. Also, as we know, many models rely on reinforced learning from human feedback. It's expensive. Another language might be as expensive as English. Why spread on that? All these factors create some kind of a softmax function that actually makes English such a dominant and overrepresented, especially if we remember that English is not even the most spoken language in the world. It shares third place. It splits third place with Arabic and trails Chinese and Spanish as the first spoken language. So, however, due to immense biases in many places, it leads to a situation where there can be only one. This serves as a motivation to our work to somehow overcome this bias and correct it, at least to some extent. So let's get to our work, datasets, and experimental setup. Again, I have already mentioned that the datasets are hard to get, and in particular, Ukrainian datasets are not that numerous, especially speaking of instruction datasets. That led us to the idea that we could contribute to this effort and come up with our own dataset, which we have called Ukrainian Knowledge and Instruction Dataset, UKID. It was created by our team specifically for this fine-tuning task, following three steps. First, we have identified around 1,000 most visited Wikipedia pages. Then, we have filtered out about two-thirds of those, leaving only those that are relevant to Ukrainian context. As you see in the table in the top right, there was a list of different articles, and we kept only those that seemed to be relevant. And then, based on these pages and using the Gemini 1.0 API, we have composed a bit less than 1,000 question answer fact triplet. So it's not only question and answer, but also there is a collection of facts. You are welcome to witness the exact prompt that we use to get these questions from Gemini LLM. The resulting UKID dataset has been made public. So in our fine-tuning, we actually relied on UNLP dataset, Squad UK, so Ukrainian part of Squad dataset, and UKID mentioned before. Training setup was a bit different for Gemma and Mistral. Gemma used the official fine-tuning guidelines from the Vertex AI platform, while to fine-tune Mistral, we use the axolotl tool. Configurations can be found in our repository using the link over here. And both times we used a workstation with 4 NVIDIA Tesla A100, 80 gigabytes on Microsoft Azure. So what are the results of our training? The linguistic benchmarking has been performed using two parts. First part was multiple choice question in two categories, Ukrainian history and Ukrainian language and literature. Second part comprised open questions with human in the loop evaluation according to CRUG system. CRUG stands for Coherence, Relevance, Ukrainian Grammar. Each answer could get 1 or 0 points in each of these categories, and the results are presented in the table below. Interesting outtakes from these results, while we see very clearly that fine-tuning does lead to increase in performance in multiple choice question, that's no doubt. However, the increase in performance is not the same in two question categories. Mostly it gives a significant boost in history questions, but very moderate in language and literature questions. At the same time, intensive fine-tuning leads to drop in open questions performance, which is also interesting, and that probably might have something to do with catastrophic forgetting. As you can see here, Ukrainian skills actually diminish in Gemma 7b after the fine-tuning step. Well, however interesting was this experiment, we thought that a decent follow-up could be very beneficial for our further efforts. So currently, we have work in progress, and we are moving towards a model with even better language capabilities in Ukrainian language. We are going to include larger corpus training. We are extending the vocabulary very substantially. We are going to add 70,000 new UA tokens in order to reduce the token to word ratio. We are using smart embed initialization of new tokens, leveraging the existing tokens. We are using Gemma 7b model as a baseline, and we modify the vocabulary and then using JAX backend and model parallelism with 8 NVIDIA Tesla A100. We do hope to come up with even better model than we already have. Thank you very much for your attention. It was a pleasure to present our work here.